All right, Rad Nation. Today we're going to be talking about exposure time, how to calculate exposure time from other factors if they're changing on your system, the technical factors including KVP, MA, SID, and Bucky Factor. All of those things are going to be important because they all impact the exposure that's given to the patient and also the exposure that's measured on the detector. In order to maintain the same exposure at the image receptor, if we have film, we want to keep the same density. If we have CR or DR, we want to keep the same noise. Problem either in the clinic or on your AERT registry exam. The idea is that we want to separate out the terms, write them clearly in a table like this so that we can understand what's the original parameters and then what's the new parameters. So we have our time here at the top. So we have our original time, and what we want to calculate is the new time. So what will be the exposure time given these change in parameters? Then we have our KVP, we have our MA, and we have our grid factor. Familiar with all these terms? You're definitely going to want to check out our other videos. We have videos on KVP, MA, Bucky Factor, and on the SID. As you can see, we have an initial time of 0.2 seconds. We're going from 60 to 69 kVp. The MA is going from 200 to 400, and the grid factor is going from 5 to 1 to 8 to 1. So we covered the exposure factors and how they're all related in a video that we'll have linked up down below. If you haven't seen that one, definitely check it out. The idea is that we want to use that equation here and go through one by one to plug the things in order to calculate what the new time is going to be on our system when we're changing these other parameters. KVP is the factor we're going to want to set first because penetration and contrast are determined by KVP, so it's vitally important. After we've set KVP, we're going to see how it impacts the other parameters on our system. So KVP, actually we use something that's called the 15% rule. We also have a video on the 15% rule. If you haven't seen that one, also check it out. But the 15% rule basically says that if your KVP goes up by 15%, you only need half of the MAS. If your KVP goes down by 15%, you need 2 times the MAS. So we're going to be using that 15% rule, but you could also just plug the numbers in and use this fifth power relationship. Typically, to keep things simple, we use that 15% rule as an approximation. And then the inverse square law is shown here. So this is the relationship for the SID and the SID new. And then the Bucky factor is right here. The grid factor is going to tell us what the Bucky factor is. We want to have those memorized. We're going to go over them here, but as a technologist, you want to have the rough Bucky factors memorized given the grid factor. And the MA and the original time in seconds is the final part of this equation. As we go through, we'll plug things in one at a time. The SID wasn't used anywhere in this equation, namely the SID is not changing in the information that was given to us in the problem. Because the SID is not changing, we can just drop that term out. So the SID term's gone. Then we'll also plug in our initial time in seconds. So we've got our 0.2 seconds plugged in there. Then we'll plug in the KVP. So the fact is, in this case, our KVP is going up by 15%. So we're going from 60. So 10% of 60 is 6. And then half of that is 3. And if you add 6 and 3, you get 9. So 15% of 60 is 9. So when we add that to 60, we get 69. So you can see that we've gone up by 15% in our KVP. So like we said, that means we need to go down in MAS by a factor of 2. So because we need to go down by a factor of 2, we're going to put a 1/2 right here. Then next we're going to plug in for the Bucky factor. But if you don't remember the conversion from grid factor to Bucky factor, those values are shown here. So you're going to want to have these memorized. In this problem, we have a 5 to 1 grid factor and we have an 8 to 1 grid factor. So the Bucky factors are 2 and 4 respectively. we'll plug those in here in our equation for the Bucky factors, and then we'll also plug in the MA. So we have an MA of 200 and a 400 here. So now you can see we could start canceling some things out. So if we go through, first we'll cancel out our zeros. That's the simplest one to do, right? Then we'll cancel out these two 4s. Then we'll cancel out these two 2s. And now we just have 0.2 divided by 2, right? So if we take 0.2 divided by 2, we just get 0.1. So that's the answer. So how do I get to this super useful calculator, you wonder? So on the top of howradiologyworks.com, you're going to click on Rad Calculators, and then you're going to see several calculators that we have. And the one that you're interested in today is about exposure time, right? That's the one we're talking about now. So if you click on the exposure time calculator, and then you scroll down just a little bit, it'll take you right here where the inputs are on your left-hand side, and then the outputs are on your right-hand side. And the one thing that's calculated is the exposure time here with this handy-dandy calculator. So the initial time was 0.2. Initial MA was 200. So KVP was 60. I skipped the SID because that didn't change. The initial Bucky was 2. Modified MA was 400. Modified KVP was 69. And not change the SID, and the modified Bucky was 4. The correct answer here is 0.1. That's what we calculated by going through the work, but it's just nice to have this calculator there so you can double check and determine the correct exposure time. Now this is our other problem that we're going to go through for you here. Again, a similar kind of thing where we lay out our original technical factors and then the technical factors for our new acquisition. So we start with the time, and again, we're going to be solving for the time here. The KVP is going from 70 to 80. The MA is going from 100 to 400, and the SID is going from 40 to 60. So in this case, the Bucky factor is staying the same, so we didn't list it here. In this case, we're going to use the same equation that we did in the last case. And the idea is that if we don't have the Bucky factor here, you can see it's nowhere listed in the table, so it's not changing. In that case, we can take the Bucky factor out. So after we've removed the Bucky factor, then we'll start over here. So we'll look at the KVP. And for the KVP, again, we want to use that 15% rule. If we're going from 70 as our initial KVP, let's calculate what 15% of that would be. So 10% of 70 is 7, and then half of 7 is 3.5. So if we add 3.5 to 7, we get 10.5. If we add 10.5 to 70, we get 80.5. And 80.5 is very close to 80. So we're going to approximate this as a 15% increase. So we're going to say for the KVP factor, we have a factor of 1/2 right here. Then the next thing we'll do is go to the inverse square law or the SID component. And in this case, we went from 40 to 60. So we'll be plugging those in. And for 40 and 60, if we're moving further away, we're going to need to take longer, right? We're going to need more MAS. And our knob right now is time to get that more MAS. So we're going to need 60 over 40, and then that's going to be squared. And then the MAS is actually increased here. So we took the MAS from 100 to 400. So we'll plug that in here. And it makes sense that as we're increasing the MA, that's actually going to lead to a shorter time, right? Because we're going from 100 to 400 MA. So now we're going to need to leave the exposure on for a shorter time due to that term. We can start to cross out a few things. Let's cross out the zeros here because we've got 2 zeros on the top, 2 zeros on the bottom here. And we can cross out the zeros over here. And then we can put our 0.5 seconds in for our original time. And then if we look at 6 squared, that's 36. If we look at 4 squared, that's 16 in the denominator. Final thing we can do here to reduce the factors a little bit is our 36 and our 4. we can cross out the 4 and we can cross out the 36 and change that to a 9 because 4 goes into 36 9 times. So you can see here now we have 9 on the top times 0.5, and then on the bottom we have 2 times 16. If we put those things into our calculator, we get 0.14 seconds. We start off with 0.5 seconds, and even though we moved further away, because we increased the MA and we increased the KVP, both of those are going to lead to higher exposures on the detector, and significantly so we ended up with a shorter exposure time. Okay, so let's double check, set the values in the calculator for this one. We wanted 100 MA at 0.5 seconds, and the initial KVP was 70 KVP. Then we wanted 40 for the initial SID, and we're just going to leave 1 for the initial Bucky. Then after the fact, we wanted 400 MA, 80 KVP, SID of 60, and we'll also just leave 1 for the final Bucky. So the idea here is we now get the answer right up here, 0.14. That's the same answer we came up with when we plugged everything in and did it on our own. Again, this is a great tool to double check your work. Do it 5 or 10 times, become a master at plugging things into this really important equation for X-ray imaging, and also watch our video on how we came up with this equation coming up.